we're going to spend today and Wednesday on rational expressions, rational functions, and then we'll move on and we're going to go to vectors after that. Now, those of you, I'm assuming some of you are going to be gone to the play. How many of you are going to be gone to the play on Wednesday morning? Wednesday afternoon, but, oh, it is afternoon. Oh, yay. Okay, good. Okay, then never mind. Okay, so we talked about the front page of this on Friday or on Thursday of last week, so that's been a while. And we filled in everything on the front page. And what we were trying to decide is how could we get the answers that we got here without looking at the graph, with just having the equations. Put your phones away, please. Phones put away, please. Now, did we do any of this? Not at all. Okay. So take a look at what we're going to do. We want to decide when is that rational expression less than or equal to 0. Well, we did that over here. The answer that you got to number 5. Graphically, what does it mean for this rational expression to be less than or equal to 0? What's it mean? Good. On or below the x-axis. So let's see if we can find that without the benefit of the graph. Now, the author goes through here and lays it out step by step for you. And here's what you're going to think. We've done that before. And the answer is yes, we have when we did polynomials. There was not a fraction part. So you are going to, I hope, think to yourself, I know we've done that before. Look at number 1, completely factor. So let's go ahead and factor that thing. Now look at step 2. It says set each factor that you got up there equal to 0. Now remember, how do you determine when a fraction is equal to 0? When the numerator is 0. When is this numerator equal to 0? When x is, good, -3 or -1. So a fraction is undefined when, because the denominator is 0. Yeah. 1 or -3, but I've already got -3, so I don't need to write it twice. Draw a number line that's divided into segments using those zeros. So you just go right down here, make you a number line. And you're going to put these numbers on it. But please put them in that order. Please don't put 1 first. Now look at step number 3. It says choose a number from each interval. Remember, you remembering this a little bit? How many sections or subintervals? Yeah, that's right. We've got 4. We've got everything less than -3. We've got between -3 and -1, between -1 and 1, and bigger than 1. We good there? Let's pick a number less than -3. -4, fine. A number between -3 and -1, -2. Between -1 and 1, please pick, thank you, and bigger than 1, fine. Okay, we're still on number 3. Determine the sign of each factor of the rational expression based on the chosen value. So here's what we're going to do. We're going to take this number -4, and we're going to substitute it here, 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 and here. And I don't care what the number is. I want to know, is it positive or negative? That's all I want to know. So when x is negative 4, positive or negative? Times when x is negative 4, positive or negative? Divided by when x is negative 4, times when x is negative 4. So I've got a negative times a negative divided by a negative times a negative. What do I get? I get a positive. So right down here, I just want you to do this. We're going to do the same thing for our other numbers, negative 2, 0, and 2. When x is negative 2, my first factor is positive times negative 2 plus 1 is a negative. Negative 2 plus 3 is positive. Negative 2 minus 1 is negative. A positive times a negative is a negative. So I have a negative divided by a negative, which is a positive. Yeah, if you can do those last two by yourself, go ahead. I'll just talk to the people on the video. If you don't want to listen, that's fine. When x is 0, 0 plus 3 is positive, times 0 plus 1 is positive, divided by 0 plus 3 is positive, times 0 minus 1 is negative. That gives me a positive divided by a negative, which is a negative. When x is 2, 2 plus 3 is positive, times 2 plus 1 is positive, divided by 2 plus 3 is positive, times 2 minus 1 is positive. That gives me a positive divided by a positive, which is a positive. You good there? Now, remember, what these circled signs are telling us is what the y value is in each of those subintervals. But if the y value is positive, what does that tell me about the graph? It's above the x-axis. If the y value is negative, that tells me the graph is below the x-axis. Good. So, tying knots, are you? Okay. No, I'm just curious. Okay. Now, we also have to decide, do these numbers make my inequality true or false? Can I let x equal negative 3? Why? Because the function's undefined there. So what I'm going to do is I'm just going to go here and I'm going to do this. And that's going to remind me, don't you dare use x equals negative 3. Can I use x equal negative 1? Does that make my fraction undefined? Nope. So I can use x equal negative 1. Can I use x equal 1? Because that makes this factor 0, which makes the fraction undefined. So you go in there and you do that. Now let's go to step 4. Because if I let x equal negative 3, then I'm going to get 0 divided by 0, which is undefined. Remember, when we factor out a common factor out of the numerator and denominator, I have a hole. So the function doesn't exist at that x value. Now, refer to the original inequality sign. In this particular one, it was less than or equal, which means the solution will be the values that make the polynomial, it's not a polynomial, it's a rational expression, negative or equal to 0. What sections of this graph then make that rational expression negative or equal to 0? So let's start with the negative part. Where? Between negative 1 and 1. Now what we have to decide is, do the endpoints make the thing true or false? What about negative 1? True, because at negative 1 that thing equaled 0. What about at x equal 1? Why did I mark it out up here? Because I don't have a hole there, I have a vertical asymptote there. Remember, you get a vertical asymptote when you have a not 0 divided by 0. Now let's go right down here and let's look at that interval, starting at -1 and going to 1. By golly, that graph is on or below the x-axis right there. That's what we're going to practice. All right, let's take a look at this one. Next page. We're going to solve this inequality, but notice it's just less than 0. It's factored already. Don't have to factor it. Say again? This is a different problem. Yeah. Okay. You factor it, but that's already done. Set each factor to 0. So what are our important numbers? And in calculus, we call these critical numbers. Say again? -2 makes the fraction undefined. What makes the fraction equal to 0? Yep. Those are our critical numbers. I basically just think what x value will make each one of those equal to 0. Okay. Make your number line. I am not going to insult your intelligence by asking you which of those numbers goes first. I don't want to use blue. How many subintervals has the number line been divided into? 4. So we're going to have to check 4 subintervals. Sir? You don't know, because, I mean, if you try to do -2 twice, it appears at the same place. So, yeah, you don't worry about what you learned in Algebra 2. I think you called it multiplicity. You don't worry about it. Irrelevant. Let's pick a number in each subinterval. -4. Crap. We're going to have to go -2.5, aren't we? And you know what we're going to do? We're going to put -2.5. Now remember, we're taking each of those numbers. We're going to start with -4. Does -4 make this, this positive or negative? That's what I want to know. Yes, we will have to square it. That's a great question. Because if we didn't, we would really be thinking kind of like what Adam said. Because it'd be twice. -4. That's a negative times a negative divided by, because a negative squared, what's that give us? A negative times a negative is positive, and a positive divided by a positive is a positive. -2.5. Oh, I didn't want that. I heard positive. -2.5. Do you have to worry about your denominator? Because when you square it, you're going to get positive. Positive times a negative is a negative divided by a positive. 0. Positive. Negative has to be a positive. So what do you get? Yep. And 2. positive, 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 and you crank on that and you get a positive. Now, let's write the answer. Oh, wait. Are there any of these critical numbers, -3, -2, and 1, that I absolutely cannot use? I cannot use -2. You go up there and you say goodbye. Now, can I use the other two in this particular case? No, why? Right, because those make the rational expression equal to 0. So, where is my expression less than 0? Well, it's less than 0 where? Between -2 and 1? Are the endpoints included? I can't use -2, can I? Because that makes the graph have a vertical asymptote. I could use 1 if it was equal to 0, but it's not, it's just less than. What about -3? Oh, snap, I missed that part. I missed that part. -3 to where? Are either one of those included? I just automatically put a parenthesis. Nope. Thank you. Let's look at the graph down here. Less than 0. What does that tell you about the graph? Where does it need to be if the y values are less than 0? Below the x-axis. Let's look below the x-axis. Between -3 and -2, and between -2 and 1. Questions? Let's move on. I think this is the last page of your notes, eh? Okay. Why don't you guys, oh no, never mind. You're not going to want to do this one by yourselves. Not this one. Does everybody have a calculator? Okay, here we go. What's the first step? Factor. Well, snap. Can't factor. Nothing will factor. That denominator won't factor. I do not have two numbers that multiply to give me 2 and add to give me 4. Crap. Huh? Now, here's what you got to think. What x values make my numerator equal to 0? 3. That's a critical number. X equals 3. What x values make my denominator equal to 0? Yeah. What x values make that 0? Well, it won't factor. You got two choices. Skip it is not one of the choices. What are your two choices? Now graph it. Complete the square or quadratic formula. Now, guys, complete the square on this one's real easy. Let's complete the square just so that you can remember how to complete the square, okay? Hey, your lead coefficient is 1, and that number in the middle is an even number. Complete the square is a piece of cake. You remember how to complete a square? Yeah, good. I'm going to, yeah, scooch. Right. If you had me in as freshman, yeah, you learned scooch. What we're going to do is we're going to move the 2 to the other side and leave a little room. Now let's complete that square. What's going to sit right here? Plus 4. Oh, but if I plus 4 on one side, I got a plus 4 on the other side. Half it and square it. So this gives me x plus 2 quantity squared equals 2. How do I solve this bad boy? Yeah, I do too. How do I solve this bad boy? Square root. So x plus 2 equals plus or minus root 2. Those are the x values that make that denominator equal to 0. You say, well, I don't know where to put those on a number line because I don't know what that is. That's why you have your calculator. Blank screen. What is negative 2 plus root 2? And what is negative 2 minus root 2? 3 decimal places. .585 or 586? Okay. And? Negative 3.414. That was probably faster than doing the quadratic formula. Those are the numbers that are going to go on your number line. Okay, let's come up with some numbers. Thank you. We can come up with easy numbers at least. Negative 1. Yeah, I can use negative 1, negative 2. Yeah. 0. 4. Great. Now, the nice thing is I don't have to worry about these numbers anymore. All right. If x is negative 4, numerator is negative divided by denominator. What's that give you? 16 minus 16 plus 2, right? Which is positive. And a negative divided by a positive is a negative. X equals negative 1. Numerator divided by, what's that, 1 minus 4 plus 2? And a negative divided by a negative is a positive. Tell me if I lose you. If x is 0, numerator, negative, denominator. Yep. So I get if x is 4, positive divided by gives me a. Are there any of those numbers I would have to throw out because they make the fraction undefined? The critical numbers. This makes my fraction undefined, and this makes my fraction undefined. Question? Wait, why are we finding out what the denominator equals? Because those are critical. It means something weird happens to the graph, either a hole or a vertical asymptote. Because I have to break the function, the graph there, because something funky happens. If you'll notice to the left of this negative 3.414, The graph is going to be below the x-axis. And to the right of it, the graph is above the x-axis. So I had to break it there because different things are going to happen on opposite sides of it. Now let's look. I need greater than or equal to 0. At x equal 3, will that be a part of an answer? Yep. Because that makes equal 0. All right, so what's our answer? Greater than. Let's do this. This one was, let's be so good, let's be exact. That was -2 minus root 2, right? So -2 minus root 2 to where? To -2 plus root 2. Neither one is included because both of them made the function undefined. Yes. Yes. Yes, that's correct. That's correct. I'm also greater than or equal to 0. How's that? This would have been in parentheses, correct. If it had just been greater than 0. You all right? Okay, we got 2 more questions to look at. I would like for you to work on this yourself. I'll work it up here and be quiet. And that way you can see if you run into any snags. So if you're watching the video, I'm just going to be quiet. I'm just going to follow the steps and be quiet. So you thankfully will not have to hear my voice for a little bit. All right, questions here? Okay, one more. this last one looks a little bit different. Why? Right. It doesn't have a 0 on one side. Can we force that to happen? You betcha. Subtract one of them. Let's make the right side equal 0. So we're going to make this say well. Please do not assume that your only critical numbers are -2 and 1. Maybe they are. But we've got to make that a single fraction on the left side. Well, snap. What's that mean we have to do? Common denominator. I'm trying to teach my Algebra 2 kids that right now. What's your common denominator? Good. X plus 2 times x minus 1. This one needs and this one needs. So I've got, what's that, 3x minus 3. Now, I'm going to just make this a plus and negative right there and distribute a -2 minus 2x minus 4. Yeah, that's fine. As long as you get this, I don't care how you did it. Yeah. If you just distributed the 2 and then distributed the negative, that's fine. No problem. Okay, so numerator is, what's the numerator? X minus 7? Okay, finish it. I'll go mute. Finish it. I said I was going to go mute and I stopped the recording. You probably want me to keep the recording up, so I'll record and be quiet. So now I'm getting ready to check my subintervals. Oops, I got a boo-boo. If x is -3, that's going to be, right? If x is -3, I don't know what I was thinking. That's still negative, right? Okay. Sorry about that. Thanks for the catch. Say again? Did I mess anything else up? Okay. I need less than or equal to 0. So less than, what have I got? How's that? If x equals 7, then I get 0 divided by 6 times, if x is 7, 9, which is 0 divided by 54, which is 0, and 0 is equal to 0. Questions? Did I do that right? Okay. So you got your steps. Do you remember doing this with polynomials? Yeah, yeah. So, huh? Yeah, yeah. I would not want to have to do this another way. This is pretty easy. Okay, we have one more lesson to do on rational functions. We will do that on Wednesday. And then we're going to vectors after that.